Hello everyone, it's Mr. Brewer. Today we're going to talk about writing chemical formulas for binary compounds. We know that from our periodic table that our A groups are defined by the number of electrons in their outer shell. We know that group number 1A, has one electron in that outer shell, one valence electron. And that one electron, it likes to donate or give away from the 1A group. Okay, in the 2A group, we know there's two, and they like to donate so that way they have full shells. If they donate that outside two electrons, they have a full shell, and that's what we want from our electrons, is to have our elements is to have nice, clean outer shells. And so elements in the 1A and the 2A actually donate electrons. 3A would also donate electrons. On the other side, 8A, group 8A has a full outer shell. They don't want to donate, they don't want to take on electrons. But 7A, group 7A has 7 electrons in that outer shell. They want 8, so they're going to gain electrons. They will take electrons. So based on whether they will donate or gain electrons, we give that whole column or that whole group, 1A, 2A, all the way through 7A, and charge. And so group 1A, because they have one electron that they're going to donate, they lose an electron when they donate it, and their positives are more than their negatives. So they are positive 1. Okay? Group 2A would donate 2, so they'd be a 2, a plus 2. If we take a look right now at your example right here, we're going to take and make compounds together. We're going to do binary compounds, meaning that two come together. Binary, bi meaning two. They come together. We need a positive charge and a negative charge to make it ionic. So if we take lithium, which has a plus 1, it's that 1A group over there. We know that it's got a plus 1 charge. If we take oxygen, it's in the 6A group, and it's a minus 2. It wants 2 electrons to fill that outer shell. Lithium wants to get rid of 1. Well, what we do in this case is if you see lithium and oxygen right here combined, lithium and oxygen combine, but we need 2 positives for those 2 negatives of oxygen. So what happens is we take 2 lithiums, each one has a positive 1 charge, and we combine it with oxygen. That way oxygen gets a donation from each lithium to fill its outer shell. And lithium gets rid of each one gets rid of its electron in that outer shell. So we have Li2O. And we call this right here crisscross. Okay? We call this crisscross right here when they come across right here. We just took this 2 and put it down here. We take the 1 and put it over here, but we don't usually write the 1s. It's not the correct way to do it. So instead, we just leave it blank. Let's go over and take a look at aluminum right over here, aluminum oxide. Aluminum, we know that's in the 3A group. So it's got a 3+ charge. Over here, oxygen, we just said, has minus 2. So we take the numbers right here and we crisscross them. Okay? And we bring the 2 over here, the 3 over here. And now my 2 is down here, my 3 is right here. I have Al2O3, aluminum oxide in this case. All right? So let's go down, and I'm going to make this a little bigger right down here. But let's take a look at our little table that we have here. Oxygen and sodium are the first 2 we're going to put together. Well, we know our cations are always positive, Na, and we're going to put right over here O. Okay? Sodium oxide. Well, if we take and we crisscross, we put our 1 over here. We don't need to write 1, but we take our 2 and we put it over here for sodium. Na2O would be a perfect example of what this is. That's the correct chemical formula for sodium oxide. If we come over here to chlorine, we take our Na, which we know is plus 1, and we take our Cl, which is minus 1. Well, their charges equal right now, plus 1 and a minus 1. So we don't write the 1s, we just leave it NaCl. All right? I'll let you do the rest, but that is what we're talking about. Have a great day, everybody.